Preview.
All right.
Hello, everyone. Hello, everyone. This is Anupam, and with me I have Todd. We are here on our show called Maker Studio. I hope you watched us in our last episode, which we did from New York Summit. We talked about our new robot, which we are building using speech. So we talked about how speech works, what happens. But let's start with the introductions. Myself, Anupam Mishra. I'm a solutions architect with AWS. And I've been with Amazon for about 9 years, working over different teams as engineers. Definitely, this is one of the most fun things which I do here. So really happy to be part of this. And Todd?
Yeah, hi, Todd Barland. I've been with Amazon for 5 years now, and I'm part of the business development team focused on Internet of Things, which is perfect for what we're doing today. So glad to be here, and yeah, now we're back from New York, and where are we today?
Oh, so today we are in Seattle. So for this season, I don't know whether it was a part of our plan or not, but our first episode was from Japan in Nagoya. That's where we showed you how different robots are being built in RoboCup. RoboCup is an event which happens every year. A lot of humanoids come there, a lot of machine learning-based or AI-based robots, which can make our home automated. And one piece of that is Amazon Robotics Challenge. So we were part of Amazon Robotics Challenge, we hosted a competition where a lot of teams from all over the world came, and they were trying to get a box of objects, and from those objects, they were trying to detect what those products are, and automatically creating orders out of that. So that was a really awesome to see how far AI and machine learning has come in last few years. There were some teams which completely crushed it. Like they had a box of products and they had orders created. And in the second episode, we were in New York Summit. We have summits happening all over the world. And we showed you a lot of projects which were built in Summit. And we showed the first part of our robot.
Yep.
What was the first part, Todd?
Yeah. So the first part of this, so this is our robot arm here. So this is 3D printed. It's got a number of degrees of freedom. It's got an end effector here, which can open and close and pick things up. And so what we did for last episode is we have a Raspberry Pi on the back here. We have a little kind of speaker that we've attached this week. And last week, what we showed was the ability to run a local wake word. And so in other words, we have the microphone running, it's just local, and we give it an activation word, and then it'll activate some Python code of our choosing. And last week what we showed is we can say, such and such blink, 3, 5, 8 times, and then the LED on the back of this Seed Studio far field array hat, $9. Seed Studio is really awesome, and it would blink. So we showed that it would take voice input and then basically make a decision on what to do. And so this week we're extending it further, where we're gonna issue a command. We didn't have time enough to change the command, so we're just gonna tell it what we told it last week. But we're gonna issue a command, and then we're gonna have it do some other things. So instead of just listening and taking action, we're actually now this week gonna have it see and take action, and then give us a voice prompt back.
Yeah, that's very exciting.
So hopefully the demo gods are with us today. And plus, I want to give a little shout out to Bob and Paul, who are part of the Greengrass service team. They loaned us some last minute parts because on the plane today something happened with my Raspberry Pi camera, so I just want to give those guys a shout out.
And for those of you who are watching our episode for the first time, we have these episodes for season 1, which has already been done. ended last month. And then this is our season 2, where we are focusing on AI-enabled robots. The first season was basic robots, where you can connect robots across the world. And if you want to watch those episodes, just go to YouTube and search for AWS Maker Studio, and you can catch up offline. And if you have questions, we also have chat, which we monitor here.
Yep.
So if you have any question, just send us a message on chat, and we will answer it live. So we definitely love interaction here.
Yeah, and well, plus the audience is part of the demo, because we're going to do some late binding on image processing. So
yeah. So let's show them what we are building here.
Okay. All right. So
what we did last episode was just a speech part, where you talk to Raspberry Pi and ask it to do something, and it does those blinking pieces. Now we are taking it to next step, which is how do we enable our robot to look around and recognize the people? Mm. So,
but we should we forgot to set up. So the idea here is to put together a number of AWS building blocks with some off-the-shelf technology to make a robot that does something interesting, right?
Yes.
So the end state, which we're shooting for next week, is that we can give a voice command to this robot arm to say, pick up this or that. So the ball or the block or the banana or the apple or whatever.
Yeah.
And then it'll actually reach out and pick it up. So we've got a little bit more work to do in the next 6 days.
Yep.
But the goal is that we can issue a voice command. The robot will listen, understand, respond, and take the appropriate action.
Yeah, so that's our goal, and I think we'll eventually reach there. We wanted a personal robot or a helper robot, which you can have in your office or home, and you can ask it to do certain things, and it does those things for you. So the thing which we started with is look around and pick objects. So the first step of that is how do we look around?
We're open sourcing all this.
Yeah, whatever we are talking, we're going to show every piece of code. All the hardware technologies, all the software pieces, and different challenges which we have gone through. So let's start with the demo.
Yep, sure.
So before we start demo, we wanted to show you 2 pictures, and if you can look at them,
right.
We want you to tell which one do you like more.
Or which one should we have the robot identify?
So we do have some already chosen celebrities, and we want to choose one of these celebrities. If you want one of them to be picked or other, just write their name in the chat, right. And we will use that person.
Okay. Anyway, I think people are being shy, so I'm just going to choose Jennifer.
Okay, so we have Jennifer Aniston here and Tom Cruise. If somebody has a last-minute change, you can shoot it.
Yeah, we can do this a couple times, too.
Yeah, so we can show it again. Yeah.
Right. So what we have here is we have a 3D printed robot arm, and then there's a Raspberry Pi camera, which is downward facing here. And so since we haven't, for next week, we're going to get the servos working. So what we're going to do here is Anupam is going to put it in the ready position.
So we have one cube which has Andy Jassy's photo on it. We're going to put it here. And another one which is
Should
Jeff
we put
Bezos.
Jennifer in as well?
Yeah, let's put all 3 of them.
Okay.
And then we're going to talk to this robot to recognize who is here.
Yeah.
And then hopefully it will tell us it will tell us which people it recognized in this image.
In what order?
Yeah.
Okay, you ready?
Yeah.
All right, so I'm going to run this command, and then we're going to issue the wake word, the same one from last week, which was, so I'm going to say Jarvis, blink 2 times. That's our wake word.
So even though we are saying blink, we are still we are using the same wake word for now, but the command when we complete this whole project would be changed to pick a specific person. We can say pick Jennifer Aniston.
Celebrities in front of me. Their names are Jeff Bezos, Jennifer Aniston, Andy Jassy. Waiting for my next chat.
Okay, so it did work.
Awesome.
Let's add either one more celebrity to this mix and see how that works.
All right.
Okay, go
You
for
ready?
it.
Okay. Let me see. Let me start it again.
So I added Tom Cruise also for people who wanted Tom Cruise.
Yeah. And I don't know if you can see this on the screen, but there's an LED here that'll blink the number of times that I tell it to. So Jarvis, blink 4 times. Okay, it's uploading the 4 meg. So we didn't optimize the image file yet, so it's doing a full like 4 meg.
Yeah, this
file
camera is
upload.
pretty high resolution, so it takes a good
Yeah.
photo, which by default is about 3 to 4 MB.
Right, here we go.
I found 4 celebrities in front of me. Their names are Jeff Bezos, Jennifer Aniston, Andy Jassy, Tom Cruise. Waiting for my next chapter.
Okay, awesome.
Awesome. So as you saw, along with the name of these people, it's also identifying where those people are on the whole project, like on the whole canvas. So that helps a lot in identifying where to move our arm. Mm-hmm. So we're going to show you that piece as well.
Yeah, and the reason that Andy and Jeff are on the blocks is next week we're going to say pick up Andy or pick up Jeff, and so that's our goal.
I found 0 celebrities in front of me.
Awesome. Good. So let's
Just a second, let me
Waiting
stop
for
that.
my next
Yeah.
chapter.
Okay, awesome.
Awesome.
Okay,
Cool. So let's jump into.
so the pieces and parts that we're using here. So we're using Snowboy, which is I don't know if it's open source or not, but it's a project you can get off the internet for the wake word.
Yep.
We're using Lex for the speech interpretation,
Yeah.
which we went over last week.
Yep.
And then this week you're adding
Recognition. Recognition is used for recognizing objects. So I'm going to show you what are different things recognition can do. And it's very, very simple. You don't need to learn AI or machine learning to use recognition, because it's an API where you give an image and tell the service to do certain things without doing all the deep learning and creating your own models. So it serves a pretty good use case where you have a specific set of requirements. You can just use recognition if it fits those requirements. And the last piece is Poly. That's a service which can talk whatever is written. So it converts text to speech, and it has different types of formats in which it can speak. It supports a lot of languages. So it's a great. So if you combine Lex and Poly together, you can build your own Raspberry Pis which talk to you in whatever way you want. You can have your own commands. You can have your own instructions. You can say, now is the time to switch off lights. You can say, bring me my breakfast, or like make me up at this time. So you can create whatever commands you want, and the Poly will speak that back to you, and Lex will make sure it understands whatever you're saying. So which piece shall we go into first?
let's do recognition.
Sure.
Right. And so just on a setup for this, so that this Python code that we worked on over the last week, or we've built up to this week, is, what do you think it's about? Probably what, with comments and constants and everything, is probably about 150 lines of Python total.
Python will be, So if you look at the AWS service calls, they're very, very simple. You just have a single API call and you get a response back. A lot of the code is just understanding that response and extracting what piece you're interested in. So these services make it very, very easy for programs to embed AI-enabled concepts. So let's start with recognition and see how it works. And for those of you who are just joining, we are using recognition for recognizing objects. And the objects which we have today is some photos of some celebrities. And we're going to show you how that works. So since you can already see my screen, let me make it a little bigger. I'll go to recognition. So when you go to recognition, it has a lot of demos. And then it has some SDKs as well, which you can use. So let's start with a simple one, which is object and scene detection. So we are not using this one for now. But what it can do is, given an object, it can tell you tags about what is in that picture. So for example, in this photo, it's telling there's a skateboard with a specific amount of probability. So it's telling how confident the system is about a specific thing in the image. It's a sport, there are people in this, and there's a person, human, there's a parking here, there's a automobile, there's a car, vehicle. So there are a lot of tags which are returned to you given an image. A lot of people use it to understand what kind of image is being shown to people automatically. Let's look at this looks like another good one. It's telling it's a downtown city. There are a lot of buildings in this. Cool. So let's go to the next one, which is image moderation. This is used for moderating images automatically. So for example, if you have specific requirements about not showing images with nudity or some other content, you can use this for blocking certain type of content. This is a female with a swimwear. Maybe you don't want to show it on your image or in website. And the third one is the facial analysis. So this is another thing which recognition can do. Given a photo, it can recognize and analyze the faces in it. For this example, it's telling there's a female in this. The female, it's predicting the age of that person, whether that person is smiling or not, and a lot of other attributes. And same goes with multiple people as well. Now, the fourth piece is celebrity recognition. This is what we were using. So given an image, it can tell us whether who is found in that image. So we already have two samples, Jesse and Bezos from Amazon. And if I use some other images, let's say I use this is Priyanka Chopra. Let's see. Oh, it found it. So it can like detect a lot of celebrities across the world. It's not just US. And then one of the interesting piece of this is if you look at the response, it's creating a bounding box around the face, and that's very, very useful because it's telling us where the face is and how to, because a lot of systems will need to find that face and do something with that face, maybe either overlap it with something or like extract it out or things like that. So it's telling the dimensions of the bounding box and where it is. One of the things we will use in one of our next episodes is the nose position. Yeah. So this is interesting because nose is generally center of the face. So it's neither left nor right. So it's center, left, right versus even top, down. It's generally around the center of the face. So what we have done is we have some cubes like this. And these cubes will try to predict or detect the location of nose of the people on these blocks. And if we can detect that position, then we know where to go and grab this cube. So if we put the cube on this platform, we will tell the robot, hey, we want to pick this person. It will first take a photo. Once it has taken the photo, it will upload it to recognition. Recognition will tell it, yes, I found the person you were looking for. And here is the position where their nose is.
So we get back as a JSON.
Yeah, so one of the interesting things, let's look at the nose of this person. So it's Priyanka Chopra. X is 0.56, which means it's almost center of the image. So if you look at it, it's slightly right side, so it's telling 0.56. If it was exactly center, it will be 0.50. And similarly, Y, it's telling 0.34, which means it's slightly on the top side. So it's
the
about
top one-third.
Top one-third of the image.
Yeah. So the top, so I think you and I were talking about this earlier, the top left corner of the image is X0, Y0. Right?
Yeah, so I can show it like in a very easy. Let's take this image for example. So this corner of the image is 0, 0. If you look at X and Y coordinates, this is X0 and Y0. If you look at this one, this is X1 and Y0. So we are still in the X-axis and we are going straight, and this is X1 and Y0. If you go all the way down on this corner, this one, we still have X as 0, but Y is 1 here. And the farthermost corner, this one, this is 1, 1. So now, based on what number, the number returned by the nose will always be between 0 and 1. And based on what is returned, you know how far to go from this corner based on XML.
And so this actually makes what we're doing really quite easy, because these end up being just percentages of the total viewable space of the camera image. So that informs basically. So if we can just apply some XY Cartesian math to find the location.
Yeah. You just need to convert it. So for example, let's say your image is let's say 5" by 5", and somebody says the X is 0.4. You just need to divide that 5 into 100 parts and see where's the 40. What is the part which is 40th in that?
Yep.
So you just travel that much.
Yep.
So it's very interesting information which we will use to pick up objects. And in one of our future episodes, once we are done with this series, we'll try to pick real objects rather than cubes with the people. If we can pick, let's say, apple, banana, or fruits like that, and maybe add some wheels to this, and then it can move around and look at different things.
So let's circle back to kind of what you talked about at the beginning, which was when you and Jeremy were at the RoboCup / Amazon Picking Challenge in Nagoya, Japan. What the Amazon Picking Challenge is in the Amazon Fulfillment Center. So when you order a product, there are these robots that bring the shelf of products actually to a person. And then the person reaches in and into the bin and tries to pick out the book versus the toy versus the what have you. And so what this Amazon Picking Challenge is it's a worldwide contest where teams are invited to build the best picking robot that they can to make it even more scalable and automated to get folks their products faster. And it's actually a relatively can be complex, kind of mechanical and computer science project. And what we're doing here is like a very small scale version of that. But I could see that maybe we'll enter the picking challenge.
So one of the things here is we want to show people how easy it is to start for simple use cases. And as the complexity increases, there will be times when you'll need your custom model to solve your specific deep learning problem. And there are a lot of material on it, and it's a very fast evolving area in computer science where a lot of research is being done and a lot of companies are building a lot of new things in that area. So coming back to the recognition piece, we saw some of the core fundamentals of what it can do. There's another last piece, which is comparison, and it can compare photos with each other. So if you have one image and you have another image, you can find whether there's the same person in those images. But let's move to the interesting piece, which is how do we use recognition from our code, and how does this piece work end to end? So let me quickly show you some of the recognition code. And I'll start with a simple thing. I don't know. Okay. I'll open another file just to keep it simple. Okay. So my original goal was to write this whole file, but I realized that if I write it, it takes so much time and it's not the most interesting thing. Given the time, we try to keep our episodes around 45 minutes. Based on the feedback, we'll try to make them longer or shorter as needed. But for now, we find that's a good balance between going in depth and also keeping it digestible and not a very, very long session. So let me start with how to call. And I'm going to show you each and every line what's happening here. So first we import Boto3, which is the library for Python, and all this code will be available on GitHub, so you can always catch up offline if needed. And we also have a page on AWS. So if you go to aws.amazon.com/twitch, we do have a page where you can find more information about this show. So this is, we import the Boto3, which is the Python library or SDK. And then we are defining a variable called image, a file name, which has the location of the image. So I'm just assuming there's an image which exists here. and then I create a recognition client. Let's not go into Poly so far, but that is another service we will use. So I created two types of clients, and then I have two functions. I'll not go into these functions for now, but let's look at this piece. So first we we open the file in a read mode, and then we assign a handle to it called image data. And then this is the only piece which is needed to recognize celebrities. So we're just saying recognition client dot recognize celebrities. So and to it we just pass the bytes of the image which we have. So the only input it needs is the image which you have. Just throw the image and it will tell you what celebrities were found.
So that recognize celebrities, that's one of the four modes of the service that you talked about.
Yeah.
So you could just swap out for one of those other modes.
Yeah, similarly you can say I want to compare faces, or you can say I want to see whether this image is safe for viewers or not.
Or tags.
Or you can have tags for the image, what objects were found. So it will be a very simple, similar call where you just change
that line right there is basically the meat of it.
Yeah, so what happens is when we call this, it is sending this image to Amazon Recognition. When Amazon Recognition gets it, it generates the response and sends it back. And so we get something called response. And this response is a JSON structure. I think if you want, we can quickly see it again. But let's say if we look at the response for Jeff's image, this is the response. It has a key called celebrity faces, and there could be multiple celebrity faces in one picture, like we showed in the demo. And what we are doing is we are looking through each celebrity faces, and we are checking which celebrities were found in this code. So let's switch back to the code. So once we have it, we are getting only the names of them by taking celebrity faces, and then finally we check how many celebrities were found. Now let's quickly check into this code, which is get celebrity names. So once we have all the celebrities, we do a for loop over all the celebrities which were found, and we are just putting it in an array named celebrity names and returning it. So it's very simple for us to understand which celebrities were found. Just loop over all the items which were found in the JSON structure and extract their name. Mm-hmm. So that's a simple piece. We can quickly show you Poly as well.
Oh, absolutely. I think we have time. Yeah,
sure.
Definitely. So recognition is basically we feed an image in a particular mode and we get a JSON object back.
Yep.
And that's really, that's about as complex as it gets. And then I'm assuming the recognition service will probably, add other features and other capabilities over time. That's the really great power of it, right?
Yep, that's the goal of it. Yeah, to make it simple for you to understand context within those images. Mm-hmm. And let's jump into Poly. If there are any questions about recognition or whatever we showed, feel free to put it on the chat, and we will take them. The Poly is a much simpler service, very, very simple to start, where you just give it a text and it tells you how that text would be spoken. So you can convert your blogs into speeches if you want. One of my colleague, Randall, did a live coding on that. If you want, you can convert your books into images. Sometimes if I have long documents to read, I convert them to audio, and when I go for a walk, I just listen to it. So a lot of interesting use cases for converting long text documents or things to the audio. And one of the best pieces is you can tune how the text will look. This is SSML. It's a standard thing where you can say how a specific text will be spoken. So for example, let me show you here in the UI. If we take, let's say, Justin, which we were using for our bot.
So Justin is the
little bit of a kid or teen voice. Let's say.
Hi, my name is Justin. I will read any text you type here.
Yeah, so this is the Justin, and then we have similarly. Let's look at Sally maybe.
Hi, my name is Sally. I will read any text you.
Yeah, so you got the idea. You can have a text and it reads for you. And with SSML, you can have custom breaks. You can say, I want to pause up after this, or I have a phone number which I want to be spoken in a specific way, or I have a fraction number, and instead of saying 22 3 by 4, you should say it something else. So things like that, you can customize those things. It also has a lot of other voices for different languages outside of English. For now, we are just using English, but
Yeah,
if you look at it,
different language.
yeah, I don't know what to write, but let's see. I'll try maybe Russian.
Yeah, sure.
Okay, there's already some text here. Let's try that.
Привет. Меня зовут Татьяна. Я прочитаю любой текст, который вы введете здесь.
Okay, so I didn't understand what it was, but I'm hoping it is something about hello. But so it's great. Like it converts a lot of text into audio, and now there are other things which we'll not go into, but I just wanted to show it at a very high level. Now let's go into the how to use this in the code. Let's go into that piece. So I'll again go back to my code. Okay, go here, copy the piece of this piece, and okay, minute. So what I'm doing is I'm just showing you the lex piece of the code, and then we'll walk through that as well. Okay, so okay, just go here. Cool. So just to keep it very, very simple, in the previous thing which I talked about recognition, we had celebrity names, and we also have the number of people who were identified. This time, what we are doing is we are creating a custom text based on what was found. So I created a prompt which says, I found n number of celebrities. It's a placeholder in front of me. Their names are, and then
variable.
And there's another variable, and then we say waiting for my next action. And as a parameter, we pass celebrity count and celebrity names separated by a comma. So it's very, very simple command. It takes count and the names of the celebrities, and it creates a custom string. And once we have that string or a text or whatever you call it, we pass it to a poly. So the poly call is also very, very simple, very similar to what we did in recognition. If you use SSML, you need to pass this, otherwise you can just remove this argument. But we are saying the output we need is MP3. The text is here, just pointing it to a variable which we already created. And then voice ID, so the name of the voice which you want to come out. There are multiple options, so you choose the name of the person whose voice you want. And then finally, it returns as an MP3 file as a streamable content. Finally, what I'm doing is creating a sound.mp3 file. And then whatever response we got from Poly, we are reading it and writing it to the file and closing the file. So if we do this, finally we'll have like a audio file, which is MP3. You can play it, and it tells you what was found in the image. So far what we talked is, there's an image in front of this robot. It will take an image, or it will look at that. It will send that image to recognition. Recognition will tell it who was found in it and where they are. And then it will send the call to Poly, where it will tell how many faces were found and what were their names, and Poly will speak it. So we just showed that demo.
Yep.
And then based on that, it just completes the end-to-end thing of what we just did. Yeah. There's another piece which we haven't gone into called Snowboy. Do you want to talk about that?
Yeah, so we went over that in our first episode, but I'll just speak about it again briefly. So there's a company called Kit AI, and then they created this software package, Python-based, and gives you the ability to use your own local wake words. So part of what we're trying to do, over these 4 or 5 episodes of building this robot is creating an autonomous, self-aware robot, right? And so that's what we're trying to have, as many things run locally as possible. And so with this Snowboy, it's a local wake word, and so I trained it. I used the Snowboy tool to train it to respond to the Jarvis, but you could change it to tomato or whatever, tomato,
whatever name you want to give it,
and then it'll activate, and then it'll launch whatever command that you specify. So that's kind of the first part is the local wake word.
Why do they need local wake word?
Well, you have to have some way to activate your code, and so there is a button on this Seed Studio far field array hat. So we could push a button, but it's just cooler just to be able to issue a voice command.
So rather than going to your robot and pushing it, hey, switch on, and now I want to talk, it is always listening, and whenever you say that specific word, it starts working.
Yeah, and it doesn't. And the cool thing also is, and you can just look at the code and see this, but it doesn't send anything anywhere until it samples that wake word locally.
So you can trigger your own custom code as soon as that word is detected.
Yeah. So one of the things that I'm going to do over the coming months is I'm going to take a Raspberry Pi Zero.
Yeah.
And this Seed Studio hat will go on a Raspberry Pi Zero, and then I'm going to plug it into. I'm going to get just a USB power adapter for my cigarette lighter for my car. I have an old car. So, and then basically what I'm going to do is I'm just going to and then plug this into my ODB2 port on my car, and so then I can ask Jarvis, what's the engine health of my car, and I can just have this do this while I'm driving down the road. And
so you can talk to your car.
I can talk to my car.
And say, car, what are you doing right now?
Exactly. Yeah.
That'll be interesting.
Yeah, and then if I used a Pi 3 and it has built-in Wi-Fi, or I could just add a Wi-Fi dongle to the Pi Zero, I could have it when I start my car automatically pair with my phone via Bluetooth. Do basically internet sharing and then connect to the internet, and this platform could go into
a lot of ideas.
Yeah, I have a lot of ideas. I want to in my home office, I want to control the blinds, and so I can say Jarvis, bunker mode, and it'll dim the lights and close the shades. And so anyway, there's many really fun things that you can do just based off the local wake word, recognition, poly.
Nice.
Yeah, all these
Any questions from audience so far?
Yeah, so let me see. Yeah, we do have. So Snow Cave has a question. My username. He's so a comment that his username had no influence on the wake word. So I know that's funny. So and it's really it's pretty approachable, and I think it's really great because the team that there's a lot of science behind these services, but this has been these capabilities, these really powerful capabilities are exposed through some really simple APIs. And
so I think it's
cool.
I think it's I sometimes feel it's a good time to be doing some work on these projects because it's so easy. You don't need like years and years of research. But there's another aspect of it, which is we do have a lot of other teams which are doing a lot of deep learning, custom deep learning to create their own systems. So if there are problems which are not solved by these APIs, there is a way by which you can go the hard route, but it is needed in certain use cases.
Well, I think it's the classic convenience versus control, right? So everything that we are showing of these episodes this season, we're emphasizing kind of the convenience part. Get going fast, get something prototyped, get it out there. But the deep learning team has many other services where you can bring your own models, you can develop your own models, and just go crazy from a science perspective. And do some really, really powerful things at scale.
Yep, there's a lot of open source software. When I was talking to a lot of teams in RoboCup, there was a team from Princeton and MIT. The way they did it was they gave all the AI related work to the Princeton and all the mechanical and robotics work to the MIT. And the Princeton team built a lot of models to see how can we recognize which product it is when there's a lot of overlap on top of each other. Like they're like some of them have only small piece of it visible. Some of them are like not cover everything else. And also the big challenge is how do you know the surface of the product which is currently being visible? Like how do you know is it what shape it is? Because if you do a 2D camera, the image also looks 2D. So this is one of the things we were trying to do here. We were like taking a photo only from the top, because then we can always find from the X and Y how far our product is. So we're gonna go deep into that next episode.
Yep.
So our hope is that during next episode we'll have this demo where you can talk to it and it picks a specific object, and then we'll show you how those motors work.
Yeah. So we're using Dynamixel servos from Robotics. And so, yeah, we'll get that. So we've got 6 days to wire this together, but we've done it before, so I'm confident we can do it again.
If there are specific ideas which you want to share, like what this robot should be doing, what we generally do is we show these episodes 5, 6 at a time. We call it a season, and then we take a break for a month or so. And again, come up with some new project based on what people wanted to see and what we could build. So if there are specific ideas, definitely either tell us on chat, or you can send an email to aws-twitch@amazon.com, and we'll look.
So that was AWS hyphen. Whoops, I'm going to type it into the chat. AWS dash. Oh, come on, stop it. So AWS. Don't spell check. Dash Twitch. You said.
Yep, at amazon.com.
At amazon.com, and I want to kind of put, because what we're going to do is we're going to wrap this particular robot up next week is the plan.
Yep.
Knock on wood, everything goes well, and then we're going to take a break for a few weeks, and then we're going to come back for season 3 in October, right?
Yeah.
Right.
Yep.
And then we're going to do another. And so what this is important is we're actually we want to showcase projects that are created by the community.
Yeah.
And so if you have a project that you want to work on, or maybe it's partially built, maybe it's already built, uses some AWS services, and you want us to possibly showcase it on one of our episodes through, either pre-recorded video or, whatever makes sense, send us an email. And because we're making a list of projects that we want to showcase in season 3, which is going to start in about 6 weeks.
Yeah, that's a great point, because we want people to create things which they always wanted to build but haven't been able to build. So if you have already built something or you're building something, we would love to know about it, and hopefully have you participate in our show or in our annual conference, reInvent in some way. So we are still working on those.
So if you've got an idea or got a project, get after it and come on the show, and it'll be really fun. We'll talk about it, and like Anupam said, there might be some surprises around reInvent. So who knows?
Yep, awesome. So just to wrap what we did today, we talked about how this robot works. What are the different things it can do? Right now, it takes a photo of objects in front of it. I took 2 photos, and I'm putting Tom Cruise and Jennifer Aniston as well. And then it can take those photos. Once it takes the photo, it's using recognition and poly to detect the photo and telling about what it just found. And we showed you some of the code about how that works. Okay. And the last piece is once all of this is done, how do we make sure that our systems can recognize this? Anything else, Todd?
No. So just wish us luck over the next week as we put the final touches on this robot, and then just reiterate, if you've got an idea or a project, drop us an email and we'll get connected about.
Yeah, email, and you can also go to our Twitter handles. Mine is Ask Anupam, ASKANUPAM. You can see it in our when our show starts. We generally show them.
Yeah.
And Todd is Todd Varland.
Yeah, at Todd Varland.
So it's
very complex.
easy. You can find it in our Twitch page as well. So if you go to aws.amazon.com/Twitch, you can find contact information there. We would love to have some participation from audience, so definitely reach out to us. And thanks a lot for watching our show today. We are looking forward to our next one where we do some real action here.
Yeah, so live from Seattle this time. This is Todd.
And this is Anupam.
And see you next week from San Francisco.
Awesome. Thank you, everyone.
Awesome.